Good morning, year 7. So we are looking at combined events probability today. So that means two or more things happening, and we want to get the probability of that. So I left you in the last video with what happens, what would be the probability of getting two sixes in a row if we were to roll the dice. Was it 1/6 again? That's the question. Well, the answer can be found by creating something called a sample space. All the possible outcomes for this experiment. So let's do a simple one first, and let's just do tossing a coin twice. What's the probability of getting tails twice in a row? Now we know that the first toss would be a head or a tail. There's our options. Heads for heads, tails for tails. So there's the first toss. And then the subsequent toss, the next toss, if I got a head the first time, I could get a head or a tail the second time. And if I got a tail the first time, I could get a head or a tail the second toss. So this is called a tree diagram, where we look at all the possible outcomes, and then we create a sample space from that. So I can get a head and head if I follow this tree, and then a head, tail, if I follow that bit. Then I get a tail, head, and two tails. So there's all the possible outcomes. Now you don't need to draw this diagram to get to here. You can probably logic it out. I have a chance of getting two heads, a head, a tail, a head, and tail, tail. They're my 4 outcomes. So there's 4 possible outcomes. So go back to the question. What's the probability of getting tails twice? Well, it happened once out of 4 outcomes. Now, from probability the last time, that would be a 1 in 4 chance. 4 possible outcomes. There's only 1 I want out of that 4, so the probability is 1 out of 4. And that's how we form probability of 2 events. So you can see it wasn't a half chance for 2 tails. So let's create something called a table for sample space for rolling a dice twice. Because if I did this tree, it's going to be 1, 2, 3, 4, 5, 6, and then each one of those is going to have 6 options off it. So it's easier to draw a table. So let's look at that. So with the first roll of the dice, I can get 1, 2, 3, 4, 5, and 6. And for the second roll of the dice, it's called a number cube in your cube today. 1, 2, second, 2, 3, 4, 5, 6. So I've made a kind of a table here. So remember, these are 2 rolls of dice. So what I'm going to do is I'm going to put them together. So if they ask you for a combined total, you would add 1 plus 1, but I'm just seeing the different outcomes. So that's getting a 1 and 1, that's getting a 1 and 2. If I'm going across here, that's getting 1, 3, 1, 4, 1, 5, 1, 6. Now if they're looking to add the dices, you would just add these 2 numbers. That'd be 2, 4, 6, and all the way up to 7. So if I want to fill out this table, this is a 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Okay. So what I want you to do is to try and complete this table in your workbook. So copy it into your workbook. It's called a sample space table for rolling 2 dice. So you need to copy this and finish it. So remember, I am trying to get down as far and see how many options or outcomes there are. So the next line is that 3, 1, 3, 2, and so on. Okay, so once you have finished your sample space, you will be able to see how often 6 and a 6 came up. So you can see all these options come up. And if you're quick off the mark, you can see that 6 and 6 will only come up once. Down in this corner down here, 6 and 6 comes up once. Out of how many are here? Well, you have to go through all the options, all the boxes once you've completed. When you add them all up, there's 36 different options. So the answer for the probability of getting sixes is one chance out of, well, there's 36 options, so combined event is 1 out of 36. There's a slightly quicker way of doing that. Now you should have that table completed in your workbook by now. Maybe pause the video, finish it, and then get on to this bit. So the probability of rolling a 6 on the dice, and if I tossed a coin, getting a tail. So that's how I'd write it. Probability of getting a 6 and a tail at the same time if I did them both at the same time. Now I could write out a full sample space, but maybe you're seeing a trend here. If I wanted to get 2 tails, I know the chances of getting 2 tails is a half and a half. The chance of getting 2 sixes was a sixth and a sixth. My answer was 1 over 36. Is there any relationship there? And if you're thinking that you've multiplied the fractions, you're right. So if I want to get the probability of a 6 and a tail, what's the probability of a 6? When I roll a dice, that's a 1 in 6 chance. And if I multiply it by the probability of getting a tail, which is 1 in 2, I can quickly get to my simple probability. 1 times 1 is 1, and 6 times 2 is 12. So 1 in 12 chance. Does that work for 2 sixes here? Yes, because 1 over 6 multiplied by 1 over 6 does give 6 times 6 is 36, and 1 times 1 gives 1. And the same here, a half times a half is a quarter. All right. So to finish off with, we're going to look at some drawing out of a bag. So I got a bag of squares here, cubes, blue and green cubes. And I want to, what is the probability of picking a green cube? So that's probability of green. So the probability of green, well, how many chances? So if I put my hand into this bag, there are 5 different possible outcomes. How many of them are green? 2. So 2 out of 5. Probability of blue would be 3 out of 5. What's the probability of getting blue twice in a row? Probability of blue, then blue. Well, 3/5. Now here's the question. When I say twice in a row, when I pull one out, do I put it back in for the second draw? Because that would affect, wouldn't it? So let's presume you put it back in, and it would be 3/5 times 3/5, which would give an answer of, let's just remove it. 3/5 times 3/5, well, 3 times 3 on top of the fraction gives 9, and 5 times 5 gives 25. And that is the probability if it's replaced. Put back in. If it's not replaced, well, the first one would be still a 3 chance in 5 when you put your hand in. And I'd multiply that by, well, remove one of the blues. That's one of the ones I picked out. Has my probability changed? Yes. There's only 4 possible outcomes, so 4 is at the bottom of my fraction. And many of them are blue, only 2 out of 4, so there's a different probability. 3 times 2 is 6, and 5 times 4 is 20, so a different probability if it's not placed. Okay, so only those doing blue probably need to worry about replaced and not replaced for the moment. Alright, so to sum up, if you're looking to get the probability of combined events, you should be able to draw a sample space. So the sample space to 2 tosses of a coin are heads, 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 tails, tails, heads, tails, tails. That is all the possible outcomes as a sample space. You can put that as a table, which you should have in your book. So make sure you have that done and finished. Copy this out and fill in these numbers, the rest of them. So the next one here would be 3 and 3. The next one would be 3 on the first dice, 4 on the second. So 3, 4. Okay? And then a quick way of getting combined probabilities is to multiply the separate probabilities. So therefore, you should be able to figure out how much chance there is of getting a 6, maybe 4 or 5 times in a row. Maybe you can experiment and see how unlikely that is, and then try it yourself. Okay, so that is combined events probability. We won't be doing any more new theory on probability. From now on, it's going to be some revision. All right, so good luck with the Kahoot and the MyMaths on this today.